All right, so let's look at problem number 9. On problem number 9, we have a 250 kilogram crate being pulled across the floor at a constant speed. So that's dynamic equilibrium. Equilibrium with a rope that makes an angle of 22 degrees to the horizon and a force applied equal to 875 newtons. What's the coefficient of static friction? All right, so we need a free body diagram. We've got the mass pulling down, mg. We have the normal supporting force pulling up. Somewhere along the way we have friction, and we have a force applied at an angle. And so that's our free body diagram. Remember, we can't take the component vectors on the free body diagram. Over here on a separate diagram, I'm going to go ahead and draw my component vectors. So force applied, which is 875 newtons. This is the x direction of the force. This is the y direction of the force. So force applied y, force applied x, and this is going to be the equal to the force times the cosine of 22 degrees, and this is going to equal the force applied the sine of 22 degrees, right? Because we're just decomposing the vectors. All right, so let's do Newton's second law in both directions. In the y direction, the sum of the forces is equal to mass times acceleration, and we know that the object is not bouncing along the floor, so the acceleration is equal to 0. So those forces are 0. So what forces do we have? Well, we're going to say that if it were to accelerate, this would be the positive direction. I'm going to have my coordinate system be like this. So this is y in the positive direction, but it's uniform motion, and x in the positive direction is this direction, and they're both uniform. So I know that everything's going to equal 0. So what forces do I have? Well, in the positive direction, I have the normal force plus the force applied in the x direction. And in the negative direction, I have the weight. And that's equal to 0. And we need to actually rearrange to solve for normal force because we need to know normal force if we're going to talk about friction. And so rearranging, I get the normal force equals the weight minus the force applied in the x direction. And force applied in the x direction, I'm just going to go ahead and write as F cosine 22. And so it looks like we can solve for the normal force. And we want to solve for the normal force because we have to figure out the static coefficient of friction. And one thing we do know is that friction is equal to mu, and this is kinetic, of course. So that's the friction kinetic times the normal force. So it requires us then to solve for something in the y direction. All right, so let's put it in. So normal force is equal to the weight. So that's 2,500 newtons. I got a big hefty crate. And we're going to subtract our force applied in the x direction. So that's 875. Whoops, sorry. I don't have the other kind of calculator. So 22 sine times 875. Oh, I wrote cosine. No one, I made a mistake here, right? Because it is actually in the y direction, so that has to be the sine of 22. So 2,500 minus 327.78, if we round up, I'll change that to be negative. So the normal force is 327.78. Normal force is 2,172.2 newtons. In the x direction, we do the same thing. We sum the forces up in the x direction. Okay. That's equal to 0 because we started some dynamic equilibrium. That's a constant speed. So in the x direction, I have the force of friction. That's in the negative direction, plus in the positive direction, I have the force applied. So that's force cosine 22, and that's equal to 0. And so force of friction is equal to the force cosine of 22, and that's equal to, well, let's do it. 22, oh, did I make a mistake here? Let me just make sure. 22 sine. Nope, we're good there. So this is the cosine way. So 22 cosine times 875. Okay, so that's 811.285, right? So a force of friction is 811.285, maybe 86 if we're going to round up, newtons, and we're trying to figure out the static coefficient of friction. Then we want to rearrange this formula for mu. So mu kinetic equals the force of friction divided by the normal force, yes? All right, and the force of friction, well, we said that's 811.286 divided by the normal force, which we have over here at 2,172.2. Newtons cancel, which is good, because we shouldn't get a unit, right? Mu is a unitless creature. So, 2172.2. And we get a static coefficient of friction 0.3735, which we can round up to 0.373. Okay, hope that helps.